Imagine building a busy restaurant where the chef remembers every single customer's order history, dietary restrictions, and even their favorite table, all without writing anything down. That sounds like a recipe for chaos, especially as the restaurant gets busier. In the world of web services, managing client information in a similar way can create significant challenges. A stateless server architecture is fundamentally defined by the fact that the server does not store any client session data between requests. Each request from a client to the server contains all the necessary information for the server to fulfill that request, without relying on any prior interactions or stored state on the server side. This means every request is treated as independent and self-contained. The core mechanism behind this statelessness is that any data required to process a request, such as user authentication tokens, preferences, or transaction details, must be sent by the client with each and every request. The server processes this information, executes the requested operation, and then sends back a response, immediately forgetting any specific details about that particular client session. This contrasts sharply with stateful architectures where servers might hold onto session variables, user logins, or shopping cart contents across multiple interactions. For developers and architects, this principle has profound implications. Implementing a stateless design typically means relying on client-side storage mechanisms, like cookies or local storage, or passing tokens with each request to maintain continuity from the client's perspective. It also often involves externalizing session management to a separate, dedicated service, or embedding relevant session information directly into tokens, such as with JSON Web Tokens, or JWT. This approach shifts the burden of maintaining session state away from the individual application servers. One of the significant advantages of this approach is enhanced scalability and resilience. When a server does not retain client-specific information, any server in a cluster can handle any client request. This enables horizontal scaling, where you can simply add more servers to distribute the load without complex session replication strategies. It also improves fault tolerance, because if one server fails, another can seamlessly pick up the next request without any loss of user context, as long as the client provides the necessary information with that request. Ultimately, embracing a stateless server architecture leads to systems that are simpler to scale, easier to deploy, and more robust in the face of fluctuating traffic and unexpected outages. By making each request self-contained, you build a foundation for highly distributed and resilient applications, ensuring a smoother experience for users even under heavy load.
If this helps you code smarter, like, subscribe, and stay tuned for more.